Okay. Hi everyone. This is Mool Shankar Kothari, co-organizer of Abu Dhabi and Dubai Meetup Group. Thank you all for joining us today. I hope you all will be doing well. Actually, we all know that it's very tough time around the world, and I hope and wish that we will get rid of this situation very soon. Today, along with Hyperledger Abu Dhabi and Dubai, Hyperledger Sweden and Toronto also co-hosting this event. So thank you, Mr. Prajeet Datta and John for doing this. I have one request. In few webinars, I have observed that most of us are at home and with the family. So there is there is a voice background in the background, and that cause bit disturbance. So I request you all to mute your microphone. If you have any questions or suggestions, you can type in the chat or unmute at that time while asking the questions. So at the end of the presentations, we also have a Q&A session. So you can ask your questions at that time as well. So thank you for your cooperation. Today, the topic of the webinar is prevent subscriber fraud in the telecom. And our guest speaker is Mr. Narendra Nath Reddy. Narendra is an experienced full stack blockchain engineer and a Hyperledger expert. He has experience of many production ready enterprise grade blockchain backed applications. He has also won 4 hackathons in the early days of the blockchain. Currently, he is working as a blockchain software engineer in Consensus Dubai. Recently, he has published one book on Hyperledger Fabric, and the topic means the title is Mastering Hyperledger Fabric, and that was published 5th of April and means few days back. So congratulations, Narendra, for the book. Now stage is all yours. Thank you very much for your time, and yes, you can proceed.
Thank you very much, Shankar. It was a warm welcome. Thank you very much. And hi, everybody. So this is Narendranath. I hope you are all good in this panic situation. Like I can say, it's like a world war situation all over the world. Apart from that, you guys spare some time and then join to this webinar. I appreciate that. Thank you very much. Confirm me, are you all able to see my screen?
Yes,
yes, we can.
Yes.
See.
Cool. Thank you. Okay. So this entire presentation or like a webinar is focusing on the telecom by taking one small use case, that is subscriber fraud, and we'll show the architecture of the DApp, and then a live demo, and then we'll speak about a little bit about my book, and then we'll go to Q&A. I'm not able to go. Okay. So the agenda is, let's talk about some problems in the telecom, how blockchain will be able to a perfect fit to solve those problems, and then the subscriber prevention of the subscriber fraud use case explanation. Later we'll jump into the business network. This is purely in the Hyperledger fabric. Designing the network topology. Let's see the chain code data model. This is like completely a technical, a developer oriented, and plus a little bit business over there. uh, the business real problem, what we are going to solve with the Hyperledger fabric. And there will be a demo. I'll show you the live demo. Actually, this topic is picked from the book itself. So in the book, I had total 3 use cases. So I picked up one of the use case, and I'm explaining to you guys. And we'll show you the monitoring the Swarm network, because this use case I'm developing and deploying into the Swarm. So we'll show you this monitoring as well, and then discussion about the book, and then the Q&A. Okay, let's see the current problems in the telecom. The first main thing is, as we all know, the identity theft or identity fraud is happening in the telecom, and then uh, due to this, almost 29 billion US dollars has been like thrown away. Recently, in 2018, there is a survey from Communications Fraud Control Association. They just told, or they just gave us the statistics that most of the telecom or like CSP providers, they lose a lot of money, which is almost greater than 29 billion US dollars, just because of the identity fraud is happening over there. So one is the identity fraud, and then second one is the as uh, in the entire world, one CSP is not at all enough. So as we move along from different countries, different regions, so we will be able to cross the borders, and then we will be able to reach the uh, different CSP networks. So at the end of the day, so all these CSP networks need to come to a conclusion regarding the payments, regarding the call detail records, CDRs. So there is a huge potential use cases are there in at this scenario, like settlement of the CDR by the, as of now, all the settlements happening through the clearance houses. A huge money is being spent by the CSPs in order to settle their invoices. That is the second one where the blockchain can be able to fit in order to settlement their invoices in a real-time manner. And the third one is, as we all know, the 5G is approaching, almost approached, even in Dubai also almost. So there will be a challenge when the 5G is fully implemented. Getting the full speed node, I mean, without blockchain, getting the full speed node, accessing points to all users will be a very difficult. So as we all know, the blockchain is the global records. Everybody has the record. Every node has the record. So example, I'm at the metro station. So I need the full internet access with unlimited bandwidth and then full speed with the 5G. So the nearest node need to be fully synced with the other nearest node. So, and then the getting access through the different accessing providers, WLAN, Wi-Fi. So all these also will be connected through the blockchain. So here also a potential use case is present for the telecom industries. So if we see the graph, this is I just bought from the TM Forum 2019. So here the potential opportunities for the blockchain here is at this settlement. As we already know, the call detail records, invoice settlements between the CSPs. That is one, and second thing is about roaming. So this is where the fraud mainly occurs, as the users will will cross the borders, and then because of the client server architecture as of now, every CSP has very limited access, very limited view. That's where the potential hackers or like a fraud uh, is going to happen in this area itself. And the payments. So the payment between different CSPs through blockchain and identity management. So here the identity management, how we can take advantage here is we all know there are one public key and one private key. So irrespective of either asymmetric or symmetric, it's just so for identity in the blockchain, there will be a one private key and associated public key will be there. So the private key will be installed in the SIM. This is like just a potential use case over here in the identity management. And then so whenever the SIM is activated, the public key will be stored in the blockchain. Let's say ATN, I'm the customer of Vodafone. I bought a SIM, and then the SIM is activated with a private key, and my public key is instantly uploaded to the blockchain. And then it will be shared with other entities as well, like AT&T, Verizon. So here I'm just telling how the identity management and authentication will be able to perform in the telecom through the blockchain. So the self-sovereign identities. So these are all the main potential use cases, and those are all the problems in the telecom. Any questions so far? Shall I move forward?
Yes.
Thank you. Okay, let's see. We have been discussing like the problems in the telecom and the use cases, but is there any either graphical level or any results that is any CSP is already implemented? Yes, it's been almost a long time since the evolution of the blockchain happened, and in the Europe, Telefonica, they already started implementing the blockchain across all the streams in the telecom. If we see the graph here, the distributed ledgers at the left side and artificial intelligence second, extended reality, quantum computing. So in the telecom, we know the artificial intelligence is a must, AI, and in the future, the quantum computing also. I can see some of the people are typing. Okay, shall we, Molshankar, shall we take the question now, or shall
Yes,
we
it's better
continue and then?
to. It's better. It's better to be interactive, and we should take the questions. I think we should take so that it will be easy for others to understand.
Okay, what are the problems are we trying to solve for some authentication? Okay, more into my use case itself here. We can say the main problem here is the SIM cloning. So using the same identity, using the same like same IMEI number from the mobile, and taking the SIM and then cloning the SIM, and a person has one SIM example, and the fraud or like the another person is able to get that SIM through the cloning technology, and then he will be able to utilize all your services. He can able to get the OTP, and then so that is where the main one potential use case over there.
Narendra,
Yeah, it's
I think we see if it's means you can see that if your presentation has the answer in these questions, so you can carry on. If its answer belongs to or questions belongs to that slide, you can take it. Otherwise, means it's up to you how you go.
yeah, sure. Cool. The private key, public key, that is just one use case on top of the blockchain. So yeah, I know there are existing identities already there, authentication mechanisms already there. This is one of the way since to achieve the complete blockchain over there to authentication. If we upload the public key over there in the blockchain, so that you can able to at every stage you can able to authenticate and can able to communicate with other entities through the smart contracts. Okay, just moving forward. So here the Telefonica, the Vodafone, AT&T, so almost all these major CSP are already looking into the blockchain, and then they already implemented like from POC to almost the production phase. Okay, now our topic is subscriber fraud. So let me explain you the clear thing. So I'll take two countries, that's better. So one is India, and the other country is the UAE itself. A person in India uh, registered with uh, this a service provider called Airtel, and he purchased a new SIM. And then at the time, his home public network will be India. Home public virtual network will be India. And then later, at one particular stage, he just wanted to visit the UAE. So he purchased a roaming package and he moved to the UAE. So now the UAE is the roaming location, and India is the home location. Okay. So what exactly now is happening here is in the UAE. So someone cloned the particular person SIM identity, and then now he is visiting. I mean, through some routing technique, he routed to India, and then is able to uh, get all services from Indian company. So now Indian company is assuming this guy is moved or like visited partially a roaming partner, and then now the Indian company is paying money to the services being provided by the UAE. Let's say do here. So now it's like the fraud guy is now utilizing the cloning identity, and then is taking the all services from Indian company, Indian CSP. So the Indian CSP is now paying the money to the UAE CSP. So this is how the subscriber fraud is going to happen. So we can take many use cases. I'm just taking how the authentication, how the subscriber fraud is going to prevent in the coming slides through the Hyperledger fabric. So in our consortium, total two organizations will be present. So one is Airtel and one is Do. So Airtel is the Indian company, Indian CSP, and Do is the UAE CSP. They both organizations join to a CSPNet channel, and then there is a one chain code. So each organization has one peer, and each organization has one orderer. So we don't have a separate organization for orderer. There is no room for orderer organization. So each organization has one certificate authority and one SDK. We're not using CLI here to interact with the organization. So this is the high level overview of our Hyperledger Fabric consortium. If you see the network topology, I'm using Kafka here. So since in my book total 3 use cases, so one use case is I'm explaining through Docker Compose, and the second use case is through Docker Swarm. And I mean the first use case is Docker Compose with Solo. Second use case is Docker Swarm with Kafka. Third use case is Kubernetes with Raft. So unfortunately the second use case is with Kafka. So that's why I'm going with the Kafka only. I'm not changing anything. The third use case has Kubernetes and then Raft. That is the supply chain use case. But I thought these use cases has the potential. So I'm just going. I'm not changing anything. So I'm just going with Kafka only. So we have the Kafka Jupyter cluster and only 2 orders. So each order from each organization. Somebody is still writing in the chat. How does Docker Swarm compare with Kubernetes? So I'll take this in the Q&A. I'll give you complete details over there. Okay, so on the whole, we have 1 channel, 2 orders, and the consensus mechanism is Kafka, the cluster, 1 peer per organization, and 1 smart contract. Okay, so this is the data model of the smart contract. So we are storing the subscriber details. So we are retrieving the information MSISDN and address is at home, status, location, latitude. This is when a subscriber is joining to the network. What do you mean by this is when a person from India is purchasing a SIM. So when he receive a signal, at the time the information will be automatically injected into the blockchain. Let's see the chain code. Are you all able to see my VS Code, right?
Yes, sir.
Yes, we can.
So the data model here for subscriber is as mentioned here. We have the inbuilt methods init and invoke. Apart from that, I just added one more function that is request authentication. So we can add as many authentications here, like by importing the CID package, we can check whether this user is coming from which organization, do this user has sufficient attributes. So all necessary authentication will be handled here, and controller will be able to route. So first it will reach the controller, and controller will call the request authentication. So as of now, I'm not adding anything for the just sake of simplicity. So this request authentication function always return true to us. And then once the authentication check is happened, then I'm passing to invoke controller. So in the invoke controller, we have total 6 functions. So first function is create subscriber. And second one is once it is created, we can query it. And the third one is we can authenticate. And the fourth one is when the person is moving from one CSP location to another CSP location, we will call the to roaming. Another one is this delete update, just ignore it. So using this construction as advantage, we can add many use cases, like we can record CDR all each and every communication details, each and every details like minutes, how many minutes a person is raised a call, and then how many minutes he really spoke. Actually, I can say like basically I'm from India. When I came to here, I just purchased a roaming package. Okay, this is the real problem I'm just telling to you. So when I purchase a roaming package, so that roaming package is giving 300 minutes, like for $25. When I make a first call, actually the first call went fine. After that, when I'm start observing that my calls are just placing, like first only 1 to 2 seconds, and then suddenly the calls are getting dropped. So at the end, the end user is losing the minutes. So here the CSP providers are not actually giving the full services. So at this situation here, the UAE CSP service provider is getting money from the Indian CSP service provider, even though the UAE service provider is not providing services sufficiently. So in that case, like even we can record how many minutes a person is really utilize the call. So those details also we can use here through the smart contracts. But as of now, I'm just focusing only on the authentication part here. So the create subscriber here will take the necessary information and it will create into the blockchain. So the ID or key is the mobile number itself here. So the fabric will store the data as binary. So as soon as we get the all the subscriber details like MS, ISDN, address at home, all these details are coming as a plain it's just a object. So we are now here converting, and then here the conversion is happening, and then we are storing here through by taking the unique ID is the mobile number itself. So once we create the record, we can able to query the record here by providing the mobile number. So I'll come to the authentication part later. The to roaming function, so what it will do is it will just change the state from is at home to true to false. This is what here. So is roaming is making to true, and then at home is making to false. So by default, is roaming will be false, at home will be true. So that is the to roaming function will do here. And then the authenticate, what it will does is, so when a user is moved from one location to another location, the corresponding CSPs will raise and will check for the authentication here. So basically what it will does is it will check if the home operator region, like now the Indian CSP is checking. If the user is from the home operator region, then it will come to this loop. And then is the particular person is at home is false, and condition with is roaming is true, then it is unauthorized. We will see this explaining this logic and then looking into this logic now a bit like harder. Maybe you can understand this logic in the live demo. So this is our the smart contract. I think I'll just go with the live demo first, then we'll come to this part. So I'm first deploying the Kafka. By the way, I have already created a swarm network. Then I'm just directly deploying. So this creates the both Jupyter cluster and Kafka cluster. So now I'm deploying the Airtel. So as we all know, I'm creating the user. Okay. So now I'm creating the channel here. Then I'm onboarding the peers. Joining peers will take a little time. Okay. Now I'm installing the chain code. So installing the chain code on peers. Now I'm adding the chain code to the channel by instantiation. Okay, instantiation is completed. Okay, now I'm creating a record. I'm creating a subscriber here with the mobile number and address. At home is true. Status is in force. Location, latitude, longitude. Is roaming is false. Home operator name is Airtel. Home operator region is India. Roaming operator name is null and roaming operator region is null. So if I create this record, we get the transaction ID. If I query, let's see whether we successfully invoked or not. Okay, we got the we got the data. So now, okay, let's see authenticate. So now the let's see the user flow now. So user is in India now, and then he just purchased a SIM. Now the user details are stored in the blockchain. Now if I authenticate here with these details, it should provide us authorized. So what is these two arguments here? So these two arguments, who you are and which region the authentication request is raised by which client. So this number is still in India itself, and the authentication request raised by Indian CSP itself. So that is why it got authorized, because the user is still in India. If I come to the chain code now, here in the authenticate part, so the aux0 is the user ID, that is mobile number, and the one, this is the from where the authentication request came. It will check if this mobile home operator region, that is India, okay, and the request also came from India. Then what we will check is at home is false and is roaming is true. It means if the roaming is true, means the user is in another country, move to another country by enabling the roaming. Some fraud has cloned his identity and it try to utilize the services from India. And when the authentication raised, it will check if the is roaming flag is true and is at home is false. It will immediately give us unauthorized. I will show you this. So right now it didn't happen. So is at home is true and is roaming is false. That's why we got authorized. This is why we got authorized. So if now let's see, we are authenticating the same user from UAE. As of now, the user is not moved from India to UAE, but still, see, unauthorized. Now what I'm doing is, let's make this user move from India to UAE. So that is where the two roaming option will help us. Okay, we got it. If we query the data, let's see what all the fields are previously present and what all the fields are now available. Address is same. Now the home operator also same. Home operator reason is India only. Is roaming is true. Latitudes, longitudes, I'm not focusing on that. The mobile number is same. Now the roaming operator name is do. Roaming operator reason is UAE. Status is inputs. So now the user is successfully moved from home location to a roaming location. Let's see now his identity has been cloned by some other person and is trying to utilize the services from India. Let's see now, if the blockchain is not there, the Indian CSP will still provide the services for both guys. It will still need to pay for a huge invoice by the UAE do CSP, and then the fake user from UAE. So this is where we are trying to cross cut this. Now let's see, authentication raised by Indian CSP with the same mobile. Now it is providing unauthorized. If we come to the chain code part, how this is happening here. Now, this one, home operator reason is India, and supplied also India. Is at home is false, and is roaming is true. That's why it is unauthorized. Someone is writing messages continuously. How can we know if he is at home or roaming? This is like the okay. To answer this, let me come to the actual situation here. How the demo is fine, but how actually the CSPs will integrate the blockchain system here? Let's see, for the first time, a user is created or a user is purchased a SIM. For the first time, when he get the signal.
Can you make in present mode?
Oh, okay, cool. Okay.
You.
So when the user get the signal, so through the cell phone tower, the core system is actually there. We are not touching any core system. And the core system, as soon as it receives the signal, and then it will add a record over there in one of the nodes. So let's say this peer is Airtel peer. Through the syncing, it will be the ledger will be able to available since the other do CSP also will be present in the same channel. So they also will get the record instantly. So when this user is actually moving from one country, from India to the other country, so when the signal drops here, and as soon as the signal uh, uh, raises here, um, beyond the blockchain, the visited public mobile network, that is the do, will initiate a request to the Indian CSP and initiate a roaming services. At that time, the Indian CSP will mark this as roaming is true. I hope I answered your question. So this is how the blockchain will be able to prevent the subscriber fraud through the authentication. This is actually a just one small use case in a very big, in a broad area in the blockchain with telecom. Do you guys have any questions before I move to monitoring the our blockchain itself? Shall I continue on, and shall we take the questions at the Q&A side, Q&A, or this? I'm open to you guys.
If you have any questions, and I know this is a bit complicated use case, so it's better if you have any questions you can ask. Otherwise, we have a Q&A session in the last. I think you move on.
Cool, thank you. Okay. So, sorry. Okay, now there is a open source tool called Swampit. If we open, this is very nice. So installation will just happen with one command. So I'm just running that now. Basically, it will give the complete information of all Docker containers. So actually, this area is more a bit technical, and then for the developers only. So I'm just going for the defaults. So the password is admin1234. So I have talked about this Docker sockets in my book very broadly, explaining complete functionalities by Docker socket, how any services, Swampit or Runkit. So it's like many are there that trying to take the advantage from the Docker itself through the Docker API. Even in fact, the Hyperledger fabric also, how the chain code containers are creating on the fly to us, how the Hyperledger pair is able to maintain that through this. I mean, I'm talking about the version 1.4.x, not with the 2.0. 2.0, we have a lot of other availabilities. We can run the chain code itself as a service. That is beyond the thing, but the main here is with the Docker socket, even Swampit will be able to access complete information of your Docker containers. So Swampit itself will deploy to our Swarm, and then it deploy an agent to each node in the Swarm. As of now, I have only one node, that is my laptop, that is the Docker desktop, and it will create a network overlay network, and it has a DB as well. Let's wait for the Swampit up and running. It will be live at the port 888.
You run with the default setting, this one.
Yes, default setting. I'm not changing anything. We can give any stack name over here. We can give whatever port we want. Okay. For some reasons, Swampit will fail because of like CPU utilizations or RAM. So what we can do is let list what exactly happened. Okay. Okay, we have Swampit. Let's delete this. Docker stack rm. Okay. No. I'm not sending any curl commands to Swampit API. So those curl commands I have exposed in Node.js application. So that has the Fabric Node SDK is there. So Swarm will automatically will be deployed into our network. Swampit will be automatically deployed to Swarm network. Then it will collect all the data intelligently, and it will open a dashboard. I'm trying to open the dashboard. Just give me some time. Okay. Yeah, sure. We can take the questions. Yes, GitHub repo is there. I've added even the Kubernetes complete manifest, the Node.js application, and even the Docker Compose, even the update channel with Node.js itself, Node SDK itself. So GitHub link will be in the book. I'm sorry, I cannot just because this use case is picked up from the book. I can share the PPT, but the GitHub repo you will get from the book itself. Okay. Meanwhile, I can switch to the book. I mean the next slide. Okay. So this is the book that we are talking. Just give me 1 second. It's very slow here. Okay. So the key features, detailed explanation of one-way and mutual TLS, detailed explanation of the Docker sockets. This is what I was referring previously, and all functionalities of CLI and SDKs. Chain code development, where I talk about multi-version concurrencies, and then we saw the controllers, the CID package. So I exposed almost many things over there, and the Hyperledger Fabric 2.0 is released, but it is not completely supported by the SDKs as of now through CLIs only. That's why I haven't included it here. Maybe it will be released with another edition. And the some of the examples that is through use cases with the Node.js SDK and Golang SDK. I've just added some snippets. I haven't used in any of the use case. And then updating the channel, onboarding a new organization through Node.js SDK. We don't need to use CLI. As CLI, you need to do a lot of steps. So we can make use of SDK, and we can use config.tx later API. So using these two, we can achieve our aim. And I got many questions regarding this. Is there any way that we can use a CI/CD directly when I upload my fixes, or when I push my code to the GitHub repo, so it should deploy to the Hyperledger Fabric peer as a new upgrade? So I've added that snippets over there in this section. Yeah, consortium setup explanation with the different use cases through Docker Swarm, Docker Compose, and Kubernetes. So a beginner from coming from a technical background, just having an idea what is Hyperledger Fabric. So after reading this, he can at least ready for taking up a project and setting up a caliper to benchmark your consortium. Monitoring the consortium with Prometheus and Grafana. So as of now, we have the metrics operations API is already there in the order and peer. So using that, we can expose to Prometheus, and then Grafana, and then the monitoring through logs, Pout, and Swampit. So this is where now we are in, and logging the consortium with ELK stack. EFK I haven't used. I used ELK stack only, and some interesting like open source tools. Like there is a tool from the Chain Heroes where you can see any vulnerabilities or any code smells in your smart contract. So this tool will be able to help you. So this is the table of contents. Total 16 chapters are there. So starting from chapter 1 to ending at chapter 6, chapter 16, there is a deep or sharp learning curve. And a dedicated chapter where we will be able to see in details of private data concepts, access control lists, ACLs, complete ACL details, and the details of draft consensus mechanism, how we can add a new order to existing channel. Is there any criteria selecting orders? If I create a ordering system with the 3 orders or 4 or 5, what is the pros and cons, and what is the real situation over here? What is the raft is suggesting here? So all these details I've mentioned over there. Let's come back. Okay, this is still failed. But let me try to access that. Yeah, I think it is fine. We are able to access Swampit. Okay, so this is the complete dashboard of the Swampit. It will show how many nodes are there in the Swarm cluster, how many manager, how many worker nodes, what is the disk size, what is the memory usage, how many cores, usage of the memory and CPU both. If we come to registers, there are nothing. If we come to the stacks, we can see total 3 stacks. One is ATEL and Kafka, and then Swampit itself. If I click the ATEL stack, we can get how many services are running and what all networks, what type of network is that. And then if we come to the services itself, all the status of the services, and then if I particularly click how many replicas are present, a complete details. So if we see any so by default all these services will be also present in the tasks. So these are all overlay and the bridge networks which I have created, and overview of the nodes also, volumes. So everything, every details we can able to fetch and we can able to control from Swampit itself. So this entire magic is happening through just because Docker socket. So by default, Docker socket will be present in all systems once we install the Docker, and the Docker socket will be exposed. Its our Docker daemon API will expose its functionalities through different types. So Docker socket is one of the type. If I come to the agenda, that's it. This is what I have planned. And do you guys have any questions? Now open for the questions.
I think
And
few people already type few questions if you look around.
Sure.
Look into the chat.
One is about SIM authentication.
I can read for you if I can see. Is there any example of off-chain setup or identity mixer or intermediate CA? I think he's asking about the book, right?
Where is that question? Is there an example with off-chain setup? Oh, okay, that one. Identity mixture or intermediate CA. Identity mixture. If you have the real use case, then it's fine. If you want to issue each and every transaction anonymously, then it's fine. In our use case, I think we don't need intermediate CA. Also, you can good to go with root CA. You don't need intermediate CA. Intermediate CA will come when one root CA cannot handle so many requests. That's why, see, uh, since Hyperledger Fabric is using the PKI, the same public key infrastructure, that's why it has same certificate, SSL certificates concept. In the real world scenario, uh, how the authentication is happening is when you just try google.com, or like when you try youtube.com, a request will go to the YouTube server, and the authentication will happen with the Google Chrome and the YouTube server. Google Chrome needs to trust the server certificate. So how this trust is happening? So through the root CA. So in fact, I have explained this SSL potential in one-way TLS and a mutual TLS with a very broad way, taking two examples. I've explained it in a clear way. You guys can just see in the book. This information is present in preview itself. Even you don't need to purchase also, just to get this information. In the preview you can see up to 40 pages. So this information is present before 40 pages, I think in the 20 or 30. I've explained these concepts a very beautiful way. So in our case, intermediate CA is not at all required. When you have too many requests that root CA is not able to handle, then you need to go with the intermediate CA. Don't just go with the fancy things. We don't need intermediate CA at all. We will not encounter such scenario. But still, you can create as many intermediate CAs as long as root CA is giving the SSL to the intermediate CAs. those many times, like we can still go ahead with the many intermediate CAs.
There is one more question. This, can you compare Docker Swarm versus Kubernetes?
Yeah, cool. Yes. So Docker Swarm, I can say it's not 100% production ready. Okay, but still you can go with the production, no issues. The way the Kubernetes is handling and the way the Docker Swarm is handling completely different. If you have, let's in the high level, if you have some POC or some small level application, I mean a consortium with 2 to 3 organizations, Docker Swarm is fine. But when we go with enterprise level and 100%, there is no downtime, and then always your consortium need to be there, not even single percent or 0.1% also downside. Then the Kubernetes, like example, I have seen some use cases with 50 organizations, 40 organizations, even in the UAE itself. We had one use case with 40 organizations. So in that case, like we are using Docker Swarm, Kubernetes itself. And the other side scenario, we got one use case with 5 organizations. We deployed in Docker Swarm itself. Apart from this, technically, Docker Swarm and Kubernetes. So Docker Swarm is by Docker and Kubernetes is by Google. In fact, the Kubernetes is their internal project. They made open source to us. Oh, Docker Swarm is not 100% production ready. The way you handle the replicas, the way you handle the services is completely different in the Kubernetes. Kubernetes is really amazing.
Okay, there is one more question. Can we mix Docker Swarm with Kubernetes?
I didn't get this question. How you want to mix Docker Swarm with Kubernetes? Because both, okay, Docker Swarm and Kubernetes both are container orchestration. So what do you mean by this? When you have the consortium with the 2 organizations, at least 2 orders and 2 peers and 2 CAs. Today you deployed and today you deployed with normal Docker Compose. You just composed instead of executing every entity, like order one time, order 2 another time. You will write a compose file and you will deploy it. Fine. After some time, some power hiccup happened, and then just the server restarted. So what will happen? The containers will be destroyed, and replica sets there will be no, because there is no orchestration is happening. For this reason, Docker Swarm, Kubernetes, these are all orchestrator, container orchestrator. It will continuously monitor the containers. It will rely on the replicas. If you say I need one replica of order, no matter what happens, Kubernetes or Docker Swarm will try to make the replica all the time. Suppose if power to that VM itself is gone, after some time when the power came back, it will try to make the replica available. I've explained this how the let's say in the orchestrator itself, how different nodes will be come to one conclusion. So I explained all this in the Raft consensus page. I can say in that chapter.
Kent, you can unmute it because we have good time. So if we can utilize that time, and we can share any other ideas anyone wants to share along with the questions. More than welcome.
Okay, Kent mentioned that Swarm controlling your organization peers, then connect via Kubernetes to outside world. You mean your applications, the business applications in the Kubernetes, and your blockchain, like Hyperledger Fabric is in Docker Swarm? You mean that?
Yes.
Okay. Yeah, you can still good to go, no issues. As I told you, if you have 3 to 4 organizations, you can still go with Docker Swarm, no issue. But if you have too many organizations with too many orders and peers, then Kubernetes is the best. And when you see the multi-tenancy approaches, now Kubernetes is matured a lot. A lot of enterprise are there, like Azure, Kubernetes services, PKS, Pivotal, Red Hat. There are many. Uh, in fact, Google Container Services also. Any other questions?
Yes. Can you give us a comparison of Raft versus Kafka?
Okay, I'll just give with one simple statement. Kafka will come with a headache and a burden because Kafka needs a Jupyter cluster and Kafka cluster itself. So total 6 services must be there. But Raft is other side is matured. I can say both are distributed consensus mechanisms. What do you mean by this here is when you have one database and I'm adding a record to that database and retrieving that record, it's fine. When we have the replica of that database, so first replica is present in VM1, second replica is present in VM2. Okay, so when I'm adding a record in the VM1, so and the other person is retrieving the same record from VM2, how these two come to a conclusion? Maybe a VM2 is down at the time, VM2 is not present when VM1 is trying to sync with the VM2. So the distributed consensus, like how these two, maybe the third replica also will come into picture. So here through Kafka, through Raft, there are many other, in fact, etcd. So there are, it's a distributed database. So how these come to the conclusion? Raft is, in fact, the Docker Swarm itself, the Swarm manager and workers, they are coming to the consensus through Raft only. So as I told you in one statement, Kafka will come with a headache, additional burden. Raft will just simple and then powerful.
Thank you.
There is one more question. Which cloud platform is preferred for enterprise application? Sunit.
Actually, depends on our depends on our use case. So we basically use PKS, and sometimes I use Azure also. So those are all enterprise, and we will have the license with them as well.
Okay. Is Amazon also being preferred right now for Fabric deployment?
Yeah, in fact, they are providing some templates. Even Azure is providing some templates. Amazon is providing some templates. Apart from that, you can still create Kubernetes containers, and you can still, if you want more insights, even in my book, one dedicated chapter is there.
Sure.
Right. Thanks. From explaining the basics in the Kubernetes, how we can achieve the complete deployment of a consortium with Minikube. If you don't want to just pay now in order to play, you can still play with the Minikube. Minikube is like a mini local Kubernetes cluster with single node. You can still play and you can still use the same manifest to deploy whichever cloud you want. Whichever enterprise Kubernetes you want.
Okay, thanks.
Any other questions? Or anyone wants to share his ideas, his or her ideas, or anything related to the topic? Okay, I think. Thank you, Narendra, for your time. It was very detailed presentation and you explain is, I hope it will be fruitful for all the participants. Thank you very much. I will upload the videos and we will share the presentations also. So you can go through it. And if you have questions, then you can, Narendra, you can share your LinkedIn profile or something. They can, or email if you want. Then they can ask a question if they have any question.
Yeah, sure. So my LinkedIn profile is I will paste in the chat. This is the Narendranath Reddy photo.
Okay. Okay. Fair enough. Thank you very much. Thank you all for your time. We finished a bit earlier. Sorry, we didn't we didn't do the introduction section in the start. Anyway, thank you very much from all of you, and stay home, stay safe, and catch you somewhere in any other webinar. Thank you all. Thank you, Narendra.